In July 1940, a new bridge opened across Puget Sound, Washington. At 2,800 feet, it was the third longest suspension bridge in the world. Engineers called it a marvel of modern design, slender, elegant, and radically lighter than anything built before it. Its designer had also worked on some of the most famous suspension bridges in America. His philosophy was simple: strip away unnecessary weight and let steel cables do the work. The Tacoma Narrows Bridge was his boldest expression of that idea, a deck so thin and flexible it seemed to defy the very concept of a suspension bridge. Almost immediately after opening, something strange happened. In moderate wind, the deck didn't just sway, it rippled, rolling in long, visible waves along its length. Drivers described watching cars ahead of them disappear and reappear as the road undulated beneath them. Workers and locals gave the bridge a nickname, Galloping Gertie. But a few engineers were uneasy. At the time, aerodynamics simply hadn't caught up to bridge design. On the morning of November 7th, 1940, winds picked up. Not a storm, just a steady wind. But this time, the deck began to twist, one side rising as the other fell. A local newspaper editor was driving across when the motion turned violent. He abandoned his car, crawling on his hands and knees back to solid ground, leaving his dog trapped inside. Within the hour, the twisting grew more extreme. Cables began to snap. And then, in front of stunned witnesses and rolling cameras, the center span tore free and collapsed into the water below. Remarkably, no people died that day. The only casualty was the dog left behind in the car. For decades, investigators studied what came to be understood as aeroelastic flutter. The disaster permanently changed how bridges are designed. Aerodynamic testing and torsional stability became standard for every major bridge built since. Subscribe for the next case in Failure Files.